All right, so we're going to talk about today is what is the Spectrum Engineering Team, kind of what we do, who I am, what do the students get involved with, and why do we do it. So, yeah, so what is Spectrum? So it's a lot easier for a lot of the other sports and teams. You very much already know what football is, what debate is. A lot of people don't necessarily know what a engineering team or what a robotics team does. So Spectrum is the engineering team for both St. Agnes Academy and Strake Jesuit. We're a joint team. And the main big mission statement of the entire program is to introduce our students to engineering and to science and kind of show them hands-on experiences of what they're actually able to do with this. We do this through a robotics program, which we're going to talk about a lot here. But there's a lot of other things that play into it as well that go into getting a better understanding of what it actually means to be an engineer and a lot of what those skills and different things are that they don't necessarily see in just their science classrooms or their other classes. We're very student focused. We're really focused on making sure we're developing our students and getting them trained and educated and having a very positive experience. We want people to be involved and want to be there and have fun. It is entirely a optional activity. There aren't any classes directly involved with it, so you won't ever be graded on anything you do in the engineering team. But we do a lot of stuff. There's a lot of skills that are involved that you don't necessarily see in all of your classrooms: problem solving, creativity, manufacturing, programming, media. We'll talk a lot about what we build and how we do all of that as we go along. We'll promote a lot of education and career opportunities. We have people come in and talk about what they do in their actual professions and in their jobs. We have alumni come back and talk about what they've experienced like in their college curriculums through engineering and science and things like that as well. We support a lot of the growth of engineering teams and programs, not just in our schools, but in schools in our communities. And we work really hard to actually develop and make it easier for people around the world to do programs like ours as much as we can. So we share a lot, we publish a lot, we do a lot of things like that to make it easier for other schools and things to do the same thing we are. We also collaborate with a lot of other schools and organizations to develop and do growth. So there's a lot of outreach involved with our program. We do a lot of different community events and different programs where we're teaching younger students as well. And there's a lot of volunteering, and there's some volunteering with other causes as well, some things around hunger and some other things we do just to provide a different perspective for our students along with the engineering side of things. These are just some of the things we think we provide to students. There's a lot of scholarship opportunities that are specifically related to the robotics programs and competitions that we participate in. A lot of outreach activities. So a lot of our students get their service hours and things through our team. We get much better at communication skills. There's some presentations. There's a lot of talking to just random people at demonstrations and things about our program, promoting our program, things of that nature. Okay, so who are we? So I'm Alan Gregory. I'm the head coach for the team. This is my 18th season doing the first robotics competition. I started as a student all the way back in 2003 when I was a freshman in high school. I went to high school in Central Texas, a school called Shoemaker High School. I came to Houston to go to Rice University, where I got my degree in cognitive science, focusing on human factors engineering and interface design. Right out of school, I did a year with AmeriCorps Vista at the Houston Food Bank. So I helped as they were transitioning into the facility they're currently in. I did a lot of process documentation and improving a lot and just making the whole place a lot more efficient and making sure it was all documented so they could get better training and things along with that. I've also done engineering consulting for like product development and things. I've also done a lot of different curriculum and robotics teaching and things of that nature, and summer camps and all sorts of things along those lines. But my main focus and has been for the last, now this is year 10, is running and coaching the St. Agnes and Strake Jesuit engineering team. In addition to that, I also am a volunteer for robotics programs both locally and around the world. So I've done I do a lot of refereeing and assisting with different teams in the state of Texas and in Houston. But I've also gotten the opportunity to go and help with programs in China once. I've done First Global, which is a program that was held in Mexico City one year, and in 2019 in Dubai. So I volunteered around the world, basically helping different robotics organizations and robotics competitions. In addition to myself, we have another mentor who actually was a former parent who's just stayed involved. Her student graduated in 2018, but Sue-Ann is now taken over a large part of our media side of the team and awards, communications. She helps with logistics and organizing all of the parents, and she's just invaluable to the program. In addition, we also have two faculty advisors, Mr. Walker and Mr. Tran from Strake Jesuit. So they help a lot with transportation back and forth to events, and a lot of the logistics with working with the Strake administration and things. So I'm a St. Agnes employee, where they're Strake employees, so it makes it easier that we have some of each. When we are doing, like I said, the team is joint, so everything is done with students from both schools. Okay, so everyone is welcome. So we do not have any sort of application process, or we don't cut anyone or anything like that. So any student from Agnes or Strake may join the team at any time. There's not like a cutoff. We have people who have somewhat interest, but maybe they decide they want to be doing a fall sport and they don't have time to do it, and they join a little bit later in the fall or in the spring. That's totally fine. Our goal, like we said, is to expose people to things that they may not have seen before and get them interested and excited, or just determine if that is something they want to pursue. So we try to remove as many barriers as we can to people getting involved and helping out and just learning as much as they can. No experience or abilities are required. If you have experience with this type of thing, if you've been in a program that was doing robotics or programming or anything, that's great, and we can build on that. But if you've never turned a screwdriver before in your life, that works too. We can find ways to get you up to speed and find different roles and places where you can learn and help and do what we need, and help get us what we're doing and get the robot built and compete and everything else. We are very flexible with time. We'll talk about this a little bit more later. We do not expect anyone to come to every meeting that we have. There's meetings almost every day, especially during a normal season. We meet almost every day. We very much don't expect everyone to be there. So we have people who are doing different clubs and activities in addition to us, and we encourage that. We want well-rounded students. You definitely do, you get out of it what you put in. So we will have some very dedicated members who are a lot more of the meetings, and they normally take on more of a responsibility with a lot of the different tasks that we're doing and things, and they become leaders on the team. And that makes sense, but we do have roles and places for everyone at any involvement level. We do ask that people are curious and interested in what the team does. There's a lot of opportunities for learning and growth and training, and we definitely want people to take advantage of those. Learn and figure out ways that your interests and skills and abilities can help the team. There are numerous ways where that can happen. We're going to talk about a lot of those today. And then we want to make sure everyone's enjoying themselves and everyone's having a good experience, so that we ask their students to treat everyone with respect and know that they're all team members and in this for the right reasons. And we normally don't have any sort of disciplinary issues or anything like that going on the team. Okay. Our team is very much our members. Like we said, we have very few adults involved, and you'll see how big this project is here in a second, and the projects that we do. So a huge amount of what we're doing has to be done by the students and the students working together. So everything we've been able to achieve, we've had multiple awards and things we'll talk about as we go through. All of that is based on having really passionate students who get excited about what we're doing, who learn a lot and are able to apply it as they go through the program over their years on the team. Dedicated students are crucial to every little bit of success we've had. It would not have worked without them. The team was founded before I was ever a part of it by students who decided they wanted to do something. They wanted a bigger challenge. So they got together students from both schools. They petitioned the administrations to be able to do this. This was all run by students, and it's been pushed by students ever since. Okay, so what is it that we actually do? So FRC stands for the First Robotics Competition. It's a program where teams of students and mentors from around the world are given a new game challenge each season. They must design, build, and operate a robot to compete with and against other teams to win matches, events, and awards, while embracing the philosophies of gracious professionalism and cooperation. More than robots, FRC teams work to expand STEM opportunities and address other community needs. So I'm going to go through and kind of break down this paragraph and kind of talk about each one of these little things and give a little bit more about them. So the first robotics competition is a part of FIRST, which is for inspiration and recognition of science technology. It was started in 1992, so it's been around for quite a while. And its vision is basically to transform the culture to create a world where science and technology are celebrated and young people dream of becoming science and technology leaders, right? We want people to go and major in science and engineering and do really awesome things with those skills. Teams of students and mentors. So this is a little bit different than a lot of other programs that exist. It's very specifically written that it's designed to be students working alongside mentors who have more skills and knowledge. So it's not just like your normal science fair where it's just the student doing the work and having to do all of the research. It's very explicitly we have mentors who are there to teach and work alongside them to solve really hard problems. The problems are intentionally really difficult to where it's not like, oh, just because you've done it before, you have an engineering degree, you can just solve it. It doesn't work that way at all. It takes a lot of effort. It takes a lot of work. It takes a lot of learning to be able to actually produce the machines that we do and compete the way that we do it. The teams can be made up of all sorts of different groups and things. It doesn't have to just be a school-based group. So there's community groups, there's teams that are run out of corporations, and various combinations of the lot, right? So we have, just like our team is made out of 2 schools, that's totally fine. There are some teams that are entire school districts. It's really open in how you want to form your team and where you get your high school age students from. Yeah, there's no restrictions on what an adult can do and what a student can do. We don't have a ton of adult presence. We have the 4 adults I kind of talked about who help organize and run things, but a lot of what we do put on the students to be able to do a ton of the design, a ton of the build and everything, where when they do come into a problem, I am there to kind of help and guide them. And sometimes I may have to solve it if I come up with a solution. That may be fine, but most of the time we're working together and we figure it out together. Students do have to be the ones who actually drive and operate the robots during the matches, though, which makes sense. It is a high school competition. From around the world. So there were, in the 2020 season, there were almost 4,000 team registered. With the pandemic, the number has definitely dropped for this year. We'll hope to get back up towards that going into 2022. But we had 34 countries, so there are a lot of countries represented. We compete against quite a few of them at the World Championship every season. We'll talk about when that is and how that works in just a little bit. But we see and meet teams from all over the place. The vast majority of the teams are from the United States and Canada, but we do have teams from a lot of different countries. Okay, so how does the actual game and challenge and things work? So each year we're given a brand new game. It's released to all of the teams at the same time on what's called kickoff. And the game objectives, game pieces, playing field, those all change every year, basically. So kind of some of the main things about how you're allowed to build the robot sometimes stay the same, but they're allowed to change all of those. So past games have involved launching balls into goals, hanging inner tubes or objects on pegs, stacking totes before, climbing or hanging from different structures, and many, many different tasks. So we never really know what we're going to do from year to year. That's part of the challenge, is having to learn how the task works and then how to build a robot to actually complete the task and do it very quickly and efficiently and score the most points. Design, build, and operate a robot. So each year, like I said, we design a brand new robot. So we're not using the specific parts from previous years. We're basically, we can use some things that we learned, but we're still designing a brand new machine. The rules for robot size and all those specifications, they've changed most years. So you wouldn't be able to use the same one because it may have to fit into a different size box. There's all sorts of different rules about how that would work. And then for most of the match, the robot is driven or operated by the students from the side of the field. So they have like Xbox controllers basically, and they're able to drive and operate the robot for most of the match. to compete with and against other teams. So this is actually where it gets very different compared to most other sports, is that most of the time if Strake Jesuit was competing against another team, they would just be competing against another school directly. In FRC, it's a little bit different. Each of our matches takes place with 3 robots versus 3 robots, and we're only building one of those robots. So we're partnered with 2 other teams. So in this picture down here, our robot is in the farthest right here, this 3847 robot. So we were partnered with these other 2 robots in the blue bumpers, and we were against these other 3 robots in red. So each of these was all built by a different group of students and mentors, and we have to work together with 2 of them to figure out our strategy for the match, what each of the robots is going to do, and how best we can score more points than our opponents. Yeah. Okay. To win matches, events, and awards. So each of the competition is broken down into pretty short matches. The matches are around 2.5 minutes long. So each match is pretty short, but you play multiple matches over a competition, and then there's an entire playoff round where eventually the winning alliance is crowned, the 3 teams who win the whole tournament after the playoffs are over. We also have awards that are based on judges. So there are judges who are normally engineers and scientists, professors and things like that from the community will come and be judges, and they'll talk to our students and look at the performance on the field and determine which robots get awards based on a variety of different things, from the robot design to also team attributes and outreach efforts. So some of the biggest awards are the Engineering Inspiration Award, which is how you help your community and how you can help other teams learn more about engineering and things like that. So a lot of the awards aren't necessarily specific to the robot, it's about the entire program. Embracing the philosophies of gracious professionalism and cooperation. So the way that this whole idea of even competing with robots sort of got started is by a man by the name of Woody Flowers. So he was a MIT professor who started a class, MIT 270, in the 70s. I think it was like 71 or so. And with that course, he basically had his students, he would give his students basically a bag of junk, basically. They'd have different objects and things inside of it. They'd all have the same bag. And they were tasked with building some contraption or mechanism, because you really couldn't build robots back then. The computers and technology just wasn't ready for that. And so it was really just like this first time people were competing with an engineering challenge in that way. And as time went on, as they got closer to the late 80s, they started building actual robots in the classroom, and that was the challenge. And that's how the whole idea of even competing with robots got started, and especially doing it in an educational sense. And his class worked really well, and he partnered with Dean Kamen to figure out, how do we get this into high schools and have high school students doing the same thing we're able to do in their MIT classroom. And 2 of the core philosophies that he brought to FRC from his courses and how he made his courses work were gracious professionalism, which is embracing competition, but being empathetic to your teammates, the competitors and volunteers at the same time. So it's nowhere near as much of a chest thumping, win at all cost environment. We're very much, everyone wants to win. We are incredibly competitive, but at the same time, we balance that with understanding that everyone at these events is all there to do something bigger. It's not just to win at the end of the event. We're trying to make sure everyone's having a good experience. Any one of those students could be a student on our team. We want them all to have a good experience so that they can go on and do great things in college and with the rest of their life. The way the whole competition is set up is it helps promote gracious professionalism, and in addition to cooperation, which is cooperating and competing at the same time. So again, like we said, we are very competitive. We want to win, but we're going to make sure we're winning the right way. We're also going to help our competitors in whatever way we can to make sure they're able to compete fairly too. So if something happens where they break something, or if they're missing some part, they can come ask us and we'll basically hand it over, no questions asked. We wouldn't want to win just because they forgot something or something broke in some way that they didn't expect. Most of the time, we're going to help them try to solve problems. Also, the way the competition is set up, sometimes they're your partner, sometimes their opponent. So you want to be making sure everyone is working well and at the top of their abilities throughout the entire experience. Okay. Like I said, we also do more than just the robotics competition. So a lot of our activities are outreach and community activities. Down here in the bottom left is our construction program. So most years in the fall, we'll have students get donated cans from a supplier like HEB, and then they have to design a sculpture out of those in relation to fighting hunger somehow. And we actually compete against other high schools and architecture firms for judged awards and things. So we get set up, and then all of the cans are donated to the Houston Food Bank. We donate about 3,000 cans a year to the Houston Food Bank from our involvement in that program. We also do a lot of demonstrations. This middle picture is a Cub Scout troop that came to our lab, and we showed them some of the equipment we have, in addition to the robots, and demonstrated kind of what we do for them. We have other groups come through as well. We'll also go to a large variety of different community events and things. We're normally at Comic Palooza, the big comic book festival. We've been to a variety of sporting events like the Texas Bowl and Houston Astros games. We do demonstrations at a lot of the different museums and things as well. So anywhere we can go where we can get an audience and we can talk about what we're doing and why we think that STEM and robotics and things are important, and potentially start more teams at different areas, we'll try to do. Over on the right is one of the courses that we do. So most summers we'll do a course up in the Spring Branch Boys and Girls Club, where they'll let us have a room for 2 weeks, and we'll teach a lot of their students some of the basics to robotics and programming, and have them come in and just get an introduction. And our students use this a lot as their senior service hours. So seniors are required to do 100 hours of service. And so this is one of the ways they set this up, is they'll do 2 weeks of teaching the students how to program and a lot of the engineering principles involved with that. Okay, we don't need to do that. Okay, what do team members do? So how does that all work? So there's a lot that's going on in what FRC is. How do we kind of break it down, and what do the team members do? So there are about 7 areas where we can kind of group the different tasks. Team members are encouraged to work in multiple areas. So it's not like you sign up and you're like, oh, I only do controls or I only do awards. We intend that you'll probably touch a pretty big majority of these at some point if you stay on the team for 4 years. You'll probably help out with almost all of these at some point throughout it, and then you kind of figure out which way you want to specialize, and you may do more of a couple of them than you do the others. But a lot of times we just may need help with something, and that's where you are that day, and that's where we'll all help and pitch in for whatever that is. Okay, so some of the things that we do. So build is kind of what I think a lot of people think of when they think of robotics and engineering. It's actually using the hand tools and power tools to actually do the building and assembly of the robot. Our lab does include quite a few tools and equipment. So we have a CNC router that's able to cut parts out of flat plate for us, a lot out of like metal and things. We have a laser cutter that's able to cut parts out of plastic and wood for us very quickly. We also have a variety of 3D printers that we use. In addition, we have some machine tools like a lathe and a mill, and then a lot of the normal shop tools, some of which you might even have in like your garage, like a miter saw, drill presses, power drills, all of those types of things too that we need for actually doing the construction of the robot. We also do build a practice field elements each year, which just take a little bit more woodworking. So we have some of that stuff as well, table saw, etc. So then almost all of our students learn some parts of this, because there is a lot of building and things that happen during certain parts of the year. Another really useful and important part of the team, and where we spend a lot of our training, is the actual design phase. So it's learning, how do we actually choose, how do we actually design what we're going to build? How do we know it's going to work? How do we figure all of that out? We use CAD software to do the entire 3D model of the robot. So we'll model everything before it gets built. either in SolidWorks or another CAD software known as Onshape. CAD is computer aided design, by the way. So we learn a lot of how to use those tools, but we also have to learn the concepts and principles that allow the robot to actually function properly. Because just because you can CAD it doesn't mean it's going to actually work in the real world. So there's a lot of actually learning the engineering principles and how the different parts work and how you actually can make something that's going to work properly when we actually do the building part. There's a lot of testing and improving the robot. So sometimes things may not work exactly like we thought when we designed it the first time. So we'll make it again and we'll iterate and we'll change the design and we'll keep making it better. And you learn a lot of the practical aspects of mechanical engineering that way through the design phase. Controls is how we actually go about implementing the entire control system for the robot. So that's the electrical and robot controller, in addition to the pneumatics assembly, which is compressed air that's used for parts of the robot mechanisms. And we also have to go through and learn the programming that's involved with getting all of this to work together and responding to the driver commands. And there is an autonomous portion of every match as well, where the robot has to drive itself for a little bit. This is probably the aspect of the team that I think people, without having been on the team or seeing it, actually realize that's really important, but it wouldn't be necessarily intuitive that people would think it exists. The strategy part of our team actually takes up a large percentage of our time actually at competition. We do have students who are dedicated to the actual driving and maintenance of the robot, but a lot of our students are actually dedicated to figuring out what all the other robots are able to do. And how we should be going about playing each match and how we should go about what our strategy should be to win the entire tournament. So we have students basically watching every single robot when they play and documenting what they're doing. So we take stats just like we have people take stats during sporting events. Our students are doing that. We build it all into a computer database. So we're able to sort and get graphs and things and see exactly how all of the robots at the event are doing. We also monitor matches from around the world, so we're seeing how other teams are playing. So if we can either adapt their strategies or things that they're able to do with their robot to make our robot better. So we spend a lot of time kind of looking at the rest of everyone else who's playing and making sure that we can be the best that we can be with all of that information. Another part of our team that is kind of the first part that expands us out to not just about the robot, but we're more closely related to like a small organization or company where we have a media department. So we have people who are at events just to take photos, basically, or that's their main job at the event. Video and video editing. We have students who do graphic design for us, making posters and logos, things like that. We have people who work on our social media pages, spreading a lot of the different things we do, making sure when we are at events, we can get photos taken and uploaded and things like that. We also have a website that gets maintained and created. There's a lot to be done inside the media side. And then awards as well. So like we already talked about at the events, there are different times where we talk to judges, and there are some different things we have to prepare ahead of time as well. So we have several people who are part of their tasks are to help with the awards, which is essay writing and material creation. We'll make a magazine each year that we produce for the judges, kind of about our team and what we've done. There's also a presentation part that you have to do at the events. So we'll have a few students who learn to basically give a short 5 to 7 minute presentation. There's like 3 of them together giving this presentation, and then answering questions from the judges as well. And then there's some more prep for students to talk to the judges specifically about our robot and what it does there, so we can win some of the robot awards too. So there's a lot of stuff that goes into the award side and just getting us ready to be competitive for awards at events. Outreach is the final thing. I think we already talked a lot about what some of those projects are, but there's a lot to be done with teaching different courses and things, especially throughout the summer. We'll do different things and different partnerships we have with different organizations to help come in and teach and instruct and talk to their students. Okay, so one of the final things is kind of what the schedule looks like for our team and how it works during the year. So kickoff is actually in January. So normally our actual season, our main season doesn't start till January. It'll be the first Saturday normally. That's the day where we all find out what the game is, and kind of learn how to play it or learn what the rules are and everything. We all find out that day. And then teams can begin designing and building the robot. I'm going to show part of the kickoff for the 2020 game, so you can have some idea of what some of the games look like.
Welcome to the 2020 First Robotics Competition, and this year's game, Infinite Recharge. An incoming asteroid shower is aimed at First City. Using Alliance droids, planetary citizens collect and score power cells, while traversing the trench run and boundaries to ensure maximum protection with an operational shield generator. Droids start on an initiation line and may be preloaded with up to 3 power cells. Droids operate autonomously during the first 15 seconds and attempt to score power cells into any of their 3 available power ports. While every power cell deposited adds equal charge to the shield generator, higher power ports earn more points. Drivers then control their droids for 2 minutes and 15 seconds of teleoperated time. Power cells are collected from one of the 5 chutes in the loading bay, and then driven across the city to be scored in the low, outer, and inner ports. Droids must score the required number of power cells to activate sections of their shield generator, and then either rotate their control panel a specified number of times, or position it to a specific color. Near the end of the match, droids race to their rendezvous point to make their shield generator operational. Alliances are awarded bonus points for a level generator switch. The alliance that earns the most points wins the match. May the Force be with us all.
All right. So you can see there that it was a Star Wars themed game in 2020. It's actually, we're playing the same game in 2021 because the season got cut short because of the pandemic. We'll be back to a normal kickoff and all the normal schedule for the 2022 season, which you all could be a part of at the earliest. We also get the entire manual, which is a lot longer. That animation is there just to kind of give an overview of how the game works, right? None of the robots actually look like that. That's intentional. They want students to have to design and build their own robots. They don't want to give away the entire design right there. They also wouldn't do it well, even if they did. The teams are better at it than the people who create the games. But the game manual goes through all of the very specific specifications on what's allowed to be used and all of that. It's a pretty big manual. It's not something we need to go through right now. All right, so then coming up after kickoff, the rest of the time between basically kickoff and our first competition is what we call build season. So it's relatively short. It's only about a month and a half. So we do not have a lot of time to do that. And you saw how complicated that game is. There's a lot of different things going on. But we have time to start figuring out the problem. So we'll do a lot of analysis to figure out, okay, what are the different tasks of the game? What are the most important? What do we want to like focus on? Then we do the entire 3D design for the robot. We'll manufacture and assemble it, and we program it. We also test and practice with it before our first event, and all of that happens in about a month and a half. Competition season is basically roughly another month and a half. It starts at about the end of February, goes into right at about the middle of April. We have district events here in Texas, which means we get basically slightly fewer teams. Most of the events are held in high school gyms. So like you can see here, we're basically in the bleachers. This was at Dripping Springs High School, I believe. We have a match where we're going to watch a sample match from what it actually looks like when our robots compete. This was from our 2020 district that we did get to play in right before all the events were canceled last season.
And here we are, qualification match.
So our robot is up
31
here in
underway
white,
here
up in the
at
top
our
left.
Dripping Springs
So that
District
first
event.
15 seconds we were running autonomous. So those first 3 balls that we shot and made were all autonomous.
In the upper goal, going to tally up, it's a Blue Alliance lead, 39-24. Red Alliance
So for the rest of the match, now we're under driver control. So we have our drivers over here in purple on the far right. We're driving the robot here in the middle of the field, and we're going around basically collecting the different balls, getting ready to line up so that we can score them.
Looking to align their shots while their teammates, 18-17, shoot from downtown. 46-10 trying to show.
And so our opponents are doing basically the same thing in blue. They're over here trying to score on their goal.
80-53 as they're able to get a few.
We also have a blue robot here trying to play defense. Basically, they'll be able to push us out of the way, whatever they're trying to do to not let our robots in red try to score.
Spring Constant going up close to that goal, while 18-17 outside the arc goes in for 2 points apiece.
All right, I'm going to skip towards the end game so we can see how the climbing works. So at the end, after we've done all the scoring, we do have this switch that we saw in the animation that we have to grab onto, and our robots will basically do a pull-up.
Can they balance this hang?
So this was our robot and our partner robot hanging together, and we did get it what was considered balanced, so we got even more points. And so we have to stay there at the end of the match, and that's kind of what the end of a match looks like. And we did win that match, so that's fun. Okay, coming forward. So after our district and regionals, we'll play 2 districts normally in March and April timeframe, and then we go on to our district championship, which is right about mid-April. So it's all the teams who did the best at the district events, and they gained it. You get points basically at those events based on how you perform. And we get to go to the district championship. So that's where basically all the best teams from Texas and New Mexico, that's the district we're in, compete for spots to get to the world championship. So the world championship is in the middle of April. There's actually 2 now. It's a little bit confusing. We're basically always zoned for the one that takes place in Houston. So it's actually at the Georgia Brown Convention Center. So we don't have to travel very far, which is useful. It's a little bit cheaper. And we earn spots there from our district championship. At the world championship, there'll be about 400 teams from around the world, all competing to try to be the best team in the world. So we, in the 2019 season, we were actually able to win our division, which is kind of like making the Final Four of the NCAA basketball tournament. So we were able to win like our side of the bracket, basically. And then we lost in basically the next bracket up with the other 6 alliances. So we were one of the top 6 alliances in the world basically for 2019. After the World Championship concludes in April, the rest of the time, basically all the way till the next kickoff, is kind of considered the off season. So what normally will happen is we'll have teams host different events throughout the country. They'll be able to borrow the fields and host different events where we can that don't necessarily count to your official season record. They're all after the World Championship, but it's there to train students and just get more experience with the robots. A lot of times these events are cheaper. We host one in July of most years called the Texas Robotics Invitational. We host it in the Strake gyms, and we invite teams from all over the southern United States. We're actually trying to expand that and get some teams from further away to come down. And it's just a good time to put on the event. We have the game and just use the robots more, so there's more learning to be done. This time is also when we do a lot of our training. So like right now we're in the fall semester, so there's a lot of training going on. We're teaching our new students how to do things, but we're also teaching the veterans and getting them more experience. There's a lot of different projects, improvements to the lab, and just getting ready for the next build season all going on. Okay, so a couple more things before I'll take questions. So like I said, we do have very flexible meetings. We don't expect anyone to be at all of them. So our meeting times can basically work around anyone's schedule. For this season, since a lot of it's virtual, we've been able to record most of them, which is very useful. So people can come and watch the recordings if they weren't able to make our actual meeting time. But basically, if we would like people to be able to participate in whatever level of commitment they think they can, and that's totally fine. As we hope that if you get excited and interested about it, you'll start coming to more, and that's kind of the goal. Okay, a couple questions that I know we get asked whenever I do this type of thing. Costs, members basically only pay for their apparel if they want to buy it, or they would if they go to competitions. They kind of have to. So that's shirts, hats, hoodies. It's not very expensive, like well less than $100 total. And then, well, and you can buy more of it and stuff because a lot of students will like trade it with other teams, so you can get shirts and hats from other teams and things, and just kind of collect it and other stuff like that. And then also a portion of the travel expenses. So normally it's students paying for their part of the hotel room if we have to travel and stay in a hotel. My contact information is there too. I'll put it in the chat if people want to copy it. And then at this point, if anyone has questions I can answer that I didn't get done through my little spiel, feel free to ask. Okay, I know I've gotten better at this, but I feel like I didn't answer everything.
How many people do you have on the team right now, or last season?
That's a good question. So our current roster is sitting, I think we have about 45 signed up. It normally gets bigger than that, but for our actual competition roster, it gets a little different. Basically, we'll sign people up in the fall, and some people will come for some of our fall events and trainings and things, but then may not actually stay for the actual competition and things. Maybe they have spring sports. It just kind of depends. We'll normally take anywhere from about 20, normally about an average of 25 or so go with us to each event. And that's with 5 to 10 people who are also involved who weren't able to make that event for some reason. They had some other conflict. So somewhere around 30-ish total from both schools are kind of actively involved in our competition season. We probably have students who play both sports. It just, like I said, it really depends on sorry, we had a question in chat. If we have people who play both spring and fall sports, we probably do. I don't know off the top of my head if we have any currently, but I know we have. And it really just depends on how they want to fit their schedule and where their practices and stuff are. Most of our meetings are after school. So it's a lot easier for students who do morning things. So I know like cross country and stuff meets in the morning. Band and choir meet in the morning, so we have a lot of crossover. It's really simple for them. But we have had students who have done football. We've had basketball players. We've had debate. We've had most organizations. We've had people figure out and do, and that's with people being pretty committed and doing it for sure. There's definitely people who are on the outskirts. Not outskirts. That's probably a bad word. Who are just here every once in a while, who still come in. They want to learn, but they don't choose to give a ton of time to it. That's fine too. Like I said, we don't kick anybody off, but you'll definitely get out of it what you put in. So it is trickier. They do have to spend possibly more time at the school. During our build season, we meet later than most other teams because there's a lot to get done. So even if the meeting starts at 3, when school ends, we'll probably have students working till 7 or 8 during the weekday. We'll have 1 or 2 or 3 or 4, depending on what's going on and kind of where we are in the process. And then we also meet during the weekend as well. So there's times to figure out how you can be involved and what you can do. It just takes getting that schedule complexity and figuring out. A lot of times it's hard